hi, you just caught me watering my lemon tree here. I hope you are thirsty to learn and to receive the bounty of knowledge of this lesson. Okay, let's start with some SQL programming. And with the agenda, what is SQL programming and why the heck is any of this stuff useful? What role does it play in a database application and the database application development process? We're going to learn the basic constructs of SQL programming and cover the 4 types of data logic: views, stored procedures, triggers, and user-defined functions. So let's talk about the what and the why of SQL programming. SQL programming is simply code that can be written in SQL. This goes way beyond simple create, read, update, and delete with insert, select, update, and delete. And some common use cases of SQL programming are when you want to do a conditional type insert, like only insert if the value doesn't exist, or you want to do an upsert, which is insert the value if it doesn't exist, update it when it does exist. You also might want to do something where you insert into table X but update a value in table Y. Another common use case is when you want to look up a value in one table and then use it to derive a value that gets written to another. And then a very common use case of SQL programming is to sanitize input. Like you go ahead and input some sensitive information like a social security number or credit card, and the SQL code finds that social security number or credit card and replaces it with a bunch of X's. All of this stuff is called data logic. It's really just a more complicated version of the create, read, update, and delete statements that are part of data management. So as you may recall, there are different layers in a modern data application. There's the presentation layer, right, which consists of code and layout. There's the business logic layer, which is the main heart of the functionality of the application. Then there's the data logic layer, which is really just responsible for reading data and writing data, okay, to whatever database we have, which ends up being the main storage mechanism for the application. So we're here talking about data logic now. So let's think about data logic a little more. Let's suppose we have some business logic, because data logic is a form of business logic. It's just the only thing that the business logic does that when it's data logic is talk to a database. So data logic can loosely be defined as any logical operation that requires more than one read or write to a database. Now, data logic can just do a single write to a database, but that's trivial data logic. We're talking about the non-trivial data logic. Such operations are candidates for their own data logic layer to minimize the network communication between the business logic and the database. Let's do an example here. Imagine you want to figure out if you want to add a user or update a user. You might first ask the database, the business logic might ask the database, does that user exist? The database says, oh yeah, that user exists. Then your business logic has to say, well, let's go ahead and do an update then. And then the database says, okay, I did the update. There's a lot of communication going back and forth between the business logic and the database, and this makes for an unnecessarily chatty, if you will, application because there's a lot of transport over the network back and forth between the two layers. So let's do a more deep dive example here where we are going to move an employee from one department to another. And let's think about the types of create, reads, updates, and deletes to the database that need to happen to make this occur. So remember, the business logic is going to grab from the user interface, that is from the presentation logic layer, information like which employee am I going to transfer and which department am I going to transfer them to. So that would then have to be transformed into some kind of SQL statement at the business logic layer So that, because all the relational database knows how to do is speak SQL, right? So we have some code over here, could be in Python or C or whatever, and it says get the supervisor ID for the hardware department. And this gets transformed into SQL code by the business logic layer. And then the SQL code gets sent to the database. The database performs a read operation and returns back a supervisor ID, 7, right? It's like you ran this in SQL Server, Azure Data Studio or whatever, right? You ran it in SQL Pad or whatever, and then you got back 7. Then the business logic layer says, okay, I got 7. Now I can transfer employee 66 to the hardware department and please update their supervisor to be 7. And this would generate another SQL statement, update employee, set department to hardware, employee supervisor ID 7, where employee ID is 66. These SQL statements are generated by the business logic layer because the only thing the database knows how to do is SQL. So at this point, the database would say, oh, I'll run this and do an update. And then you get one row affected, and that goes back to the business logic layer. So you can see I had to generate 2 SQL statements here in this case. And on top of it, we had to send 1, 2, 3, 4 things back and forth over the network. And this is a very trivial example, if you will. Now let's explore the same scenario, but let's encapsulate all of the, let me move my fat head here. Let's encapsulate all of the data logic into the database. So what I have done is I've created a program in the database called ptransfer employees, and it takes with it an employee ID and the new department. And what that does is it will then figure out who the manager is and then update accordingly. So rather than the business logic generating this select statement here, right here, rather than the business logic generating this and the business logic generating this, I push all that data logic down to the database. And then the business logic just says, I would like to transfer employee 66 to hardware. And then over the network, we're just sending this command, which says, please execute this program I wrote in the database that with ID 66 and with department hardware moves that employee into that department and in turn sets the right supervisor ID. Then this program runs and it outputs that the row is affected, which goes back to the business logic layer. This is just a request response. There's no back and forth. There's no timing issues or anything like that between the business logic layer and the database itself. So this is the essence of data logic. Data logic just does create, read, update, and delete. It doesn't do any more than that. It might make decisions about when it's going to do that kind of stuff, but by pushing all the data logic into the database, we save ourselves on a lot of additional traffic back and forth over the network between the layers and also complexity within the business logic layer itself. So when we're talking data logic, what we're really talking about is this part of the database right here, or this part of the data model right here. Data logic occurs in the external data model. We build out a user's view or an application's view of the database. It is independent of the way it's internally stored, but dependent on the way it's internally stored so that you can build the right artifacts externally to satisfy the internal structures. As we did back in this example here, where we had a supervisor ID here that we had to figure out first, right? Before we could do the update, we had to figure out who that supervisor ID was up here and then do the update down here. That's a 2-step process, right? And that's because of the way we did our implementation, right? The external model of this is just, I can call this transfer employee and it just works. It just does what I want, right? One person can program this and then another person could use it. So that's another way of looking at these different layers, if you will, within the database, especially between the internal and the external model. All right, let's take a look at what it takes to write code in SQL. And we'll start out, as we probably do most of the time with many of the things that we do in this class, with a disclaimer. And that disclaimer is that every DBMS is a little different. Okay, and they have their own way of doing SQL programming, right? And this is because what is not part of the SQL standard is something called Procedural Language SQL, or PLSQL. And that's mainly what you need to use in order to do programming in SQL. Okay, and this is based on SQL, but has more traditional programming logic, such as variables and branches and loops and things like that. And we're not going to get into a tremendous amount of deep detail here. What the point of this unit is to give you enough of an understanding of how this kind of database logic works, so that you can then, if you decide to get involved in a more detailed application, you at least know what capabilities are there and then can deep dive in then. There's no way you can spend a whole course on database programming if you wanted to. So the concepts we will learn are the same, but the specifics to each DBMS are not. And whether you learn Microsoft SQL Server, which uses TSQL, or Oracle, which uses PLSQL, or Postgres, which uses PLPGSQL, etc., these are different flavors of this procedural language SQL, and they're slightly different. Okay, so this is the one thing that you'll have to get used to. But all the concepts are the same. They all have variables. They all have ways of doing branches and checking to see if data exists in a table, etc. All that stuff is going to be there. All right, let's take a look at some variables. So a variable in T-SQL is a named memory of location, right? It's temporary. It's not stored in any table. It's just a place where you can put some data. It has an @ symbol in front of it, and the @ symbol symbolizes that it's a variable, and we can set our variable to a value, and we must pick a data type for the variable, and it must be one of the standard SQL data types. And the declare keyword is how we define the variable, and the set keyword is how we assign a value to that variable. So in this example, I'm declaring a date called birthday, then I'm setting the birthday date, then I'm printing, hey, the birthday is, and then let's cast that date to a varchar so I can print them all at once. And it says the birthday is 1999 11/30. All right. You can also take the output of a SQL statement and assign that to a variable. So in this particular case, I have a variable called student count int, and then I set that value to count the rows from students. And then what I finish with is print there are, and let's cast that number to a varchar, students in TinyU, and it says there are 31 students at TinyU. Okay. So the important thing to know here is that the SQL in this case must return what's called a scalar, which is a single row and a single column. So the intersection of a single row and a single column is one value. That's what needs to return in this particular case when you want to assign the output of a select statement to a variable. If you have multiple variables you want to assign to each column in an SQL statement, this works a little differently. And this is going to vary depending on the DBMS that you're using. But in Microsoft SQL Server, it's done as following. You create a bunch of variables. So I have a first name, a last name, and a GPA variable that I made up here. And then I'm just selecting from here. And I'm saying the value of first name, put in that variable. The value of last name, put in that variable. The value of GPA, put in that variable from this table, order by whatever. If there's more than one row returned, this will put the variables in the last row. So it's also important in this case that you only return a single row. It can have several columns, but it must be one row that you return back. Okay, let's talk a little bit about functions that are built in to SQL Server that we can use to write our TSQL code. Most PLSQL implementations have a variety of built-in functions to allow us to manipulate text, dates, do some math, etc. Here is the link for the TSQL reference right here, and this is a great place to visit if you're looking for a very particular function that you need to use as part of solving some kind of data logic problem. I obviously can't talk about every single function that's available, so we're just going to go over some of the more common functions. So the len function will tell you how many characters are in a column. The left function will extract a subset of characters from the column. So here's the column, and then this is the count of characters. So give me the leftmost 4 characters in the column. Right gives you the rightmost n characters in the column. Char index lets you find a piece of text within the column. And it's important to know that these values, unlike most other programming languages, start at 1 instead of 0. So when I ask for the left, for example, if I ask for the left 4, I get HELL. When I say, where's the char index of the comma, it's at position 6. 1, 2, 3, 4, 5, 6. In other programming languages, they start at 0, so this would be position 5. But in TSQL, it starts with a 1. Okay, so it's a little easier for those of you that aren't familiar with those other languages. And right will retrieve the rightmost 4, so this gives me ORLD, 4 from the right. And then you can combine these functions to do very interesting things. Like if I just want to extract hello, I can look for the comma and then say retrieve the left portion of the message without everything starting at the position of the comma. So I get HELLO. Okay. Let's talk some date time functions. Date part returns part of the date, so you can get the month, the year, the hour, the minute, the second. Date name returns the name part of the string, so you can get January, February, March, July, September, Monday, Wednesday, Friday. So get date gives you today's date and time. Date part month says give me the month from this date, so I get 7 for July. Date name month gives me the name of the date, which is July. Date part year extracts the year, but because this is just a time, the year is 1900. This is called the epoch. The very first date acceptable in SQL Server is 1900-11, at least for a short date, a regular date. Long date time is bigger. Then we have, I can get the hour and I can get the second. So this allows you to extract parts of the date without having to do all this string math to figure it out. So how about it's time for a demo? Let's do a demo where we use some date functions to extract the day of the week from FudgeMart v3 orders. And then after we do that, we'll pivot it so that the orders are the days of the week and the orders are in columns. Okay, just something really simple to get us warmed up here. All right, I'm out here in Azure Data Studio, and let's get ready to set the stage. I have a customer ID. I don't need to really pull the name. That's not necessary. And I have an order date. And then I have a count. This is each row is one order. And what I'd like to do is get a count of orders by order ID, or by customer name, and also include the day of the week. And I want the day of the week to be in the columns. So I need a pivot, and I need to set up my pivot first. So let's figure out how to set up the pivot. I need order ID, customer ID, and then I'm going to need part of the date, right? The day of the week. So let's do date name. And what do I want? I want the weekday. And from the order date. Let's see what we get here. So, this order was on a Thursday. This order was on a Friday. Looks good. Okay, let's call this order as order day of week. Good. Now I need to pivot this. I need to say with, source as, and then I need to make a query out of this. Okay, now this query's been named. And now I can say select everything from source, and let's pivot that source. And what am I going to aggregate? I'm going to count the order ID for order day of the week in, and how do I want to list my days of the week? Sunday, boy, it helps to be able to spell, right? Monday, Tuesday, Wednesday, I'm going to stop there, etc., right? And let's run it. And I got a boo-boo somewhere. Oh, you gotta, I always forget this. I gotta alias the pivot. Okay, so there you have it. So customer 23, 22 orders on Sunday, 20 on Monday, 18 on Tuesday, 14 on Wednesday. Customer 6, 23 on Sunday, 12 on Monday, 27 on Wednesday, or Tuesday, 20 on Wednesday. I could have put all the days of the week in there, but I'm trying to have you avoid the pain and anguish of having to see that. All right, here's some even more useful functions for you. The isNull function, we've seen this a little bit before. What this does is it performs a null check, and if the value is null, it will replace it with a value. So this allows you to set a queryable on-the-fly default value in place of null. String ag is an aggregate function like min, max, sum, and count. And what it will do is take several rows and collapse them down to a single row. So this is useful for turning multiple rows into a single row. And string split does the opposite. String split takes a single column and separates it into multiple rows. So it's similar to what you might get out of unpivot, except unpivot works on actual multiple columns. This takes the values within the column and splits them. So I don't know if we'll do a string split example right now or later, but I'm sure we will definitely get into the other ones. Let's do a couple of examples here. Oh, we are going to do with cross apply. Okay. So I'll talk about cross apply when we get to it, but cross apply is a way to do a join where you have what's called a table valued function. That is a function that returns a table, and you want to join the one table back to the table valued function and apply that function to each row. Okay, that's what a cross apply does. So I will demonstrate that. Okay, let's move on to the demo. Okay, I'm out here in Azure Data Studio and I warmed up the example already. You'll see that I'm querying the FudgeMart vendors table, and some of the vendors do not have a website. Their values are null. So instead of updating this data and replacing null with a value, I might prefer to not show nulls at query time and instead show a value in place of null. So here's how you do that. Let's say vendor. Well, I'll just show star, and then I'll generate another column, and I'll say it's going to be isNull vendor website, and when that's null, let's just say no website as vendor website 2. Yeah, we'll just do it that way. So now when I query this, I get back my rows, and then in the case where there is no website, in the column where I used isNull, I get no website. See that? Okay, so that's a use case for isNull. Let's demonstrate how string ag works. String ag is an aggregate operator. So let's pick on customers. All right. And what I could do is I could get a count of customers by state, right? I could do something like this. I could say, you know, we've done this a couple times. Let's get a count as customer count. And let's add to that the state. And then we need to group by customer state, right? You've done this before. All right, and we see, one person is in Arizona and 11 people are in California, and 2 are in New York and 5 are in Ohio. What you might want to do is get a list in a third column of all of their emails, right? So there is a column called email, right? Let's see, customer email. And then I could customer email. A problem with doing it this way is it screws my counts up. Whoop, I ran the vendors one too. It screws my counts up, right? And I could order by this, but that's not what I want. What I want is California 11 and then list all of these emails. So I'm going to use an aggregate here instead of customer email. I'm going to say string ag. And let's aggregate those emails and let's separate them with, I don't know, let's separate them with a space as emails. And I actually want count to come after before that. So I'm going to do this. There, that's better. And let's just jazz it up a little bit while we're at it. There, that looks better. And then I no longer need to group by email. And I need to fix this because it should be single quotes in SQL. There. Yeah, it looks good. Now what I get is, here's Arizona. There's the one customer in Arizona. Down here where there's 2 in New York, there's the 2 emails. One and then the other. Oh, I didn't put a lot of space between them. Let me do this. I wonder if I could put a tab between them. Let's try that. What if that works? Who knows? Let's give it a whirl. You learn something new every day. That did not work. So you put the /T in there. Let's just put 3 spaces. That way it'll be more profound and you can see. All right, so there's my 2 New York emails. There's my 2 DC emails. Here's my 5 Ohio emails. See that? String ag. It's a way to collapse a column of data into a single row as part of an aggregate operation. Very good function to use. Let's try a string split example. Let's do this. Let's just do a real simple example. Let's take text. Let's say declare text is varchar 100. And then let's set text to Tom, Dick, Harry. And then let's do this. Let's say select star from string split oops. What are we going to split on here? We're going to split the text on a comma, right? Remember, string split returns a table because it's going to tabularize line 13. So what I get back is value Tom, Dick, Harry. See that? Tom, Dick, Harry. The name of the column is always value. You can alias it if you want. Value as names. There. Good. Now, this is not usually how you use string split. Generally, the way you use it is you're going to apply string split to a table, to a column in a table. So let's see if we can dig out an example here that might make more sense to use this. So let's do this. Let's take a look at the products table. Products. Take a look at the products table. And in the products table, there's a product name. See that? And it says straight claw hammer, sledgehammer, rip claw hammer. Maybe I want to find all the hammers or find all the jackets, but I don't want to use like the like operator because I don't know if hammer is going to be in the beginning or in the middle or the end. I just want to have a more definitive way to find all the hammers or find all the jackets. So what I'm going to do is I'm going to split the product name on a space and turn it into rows. So let's just be specific here. Product ID, product name, and then we're going to say value. And then what I want to do is I want to get this from products, but I want to cross apply, which means to each row, I want you to apply this function. String split. And I want you to split on the product name. And I want you to split on a space within that product name. So 10-inch miter saw, 10-inch miter saw. 12-pack golf balls, 12-pack golf balls. Now I can search value for just hammer, right? Now I can say where value equals hammer. And this is a way to find all the hammers, whether the hammer's in the beginning, the middle, or the end. Just so happens that all the hammers are in the end, but that doesn't necessarily mean it's always going to be that case. And this actually is a better way to find hammer than to use, some kind of, like operator or something like that. Okay, so it just gives you an example of a use case of string split. Generally, this is used on columns that have they were poorly designed, and the one column has many values in it, and you need to now denormalize those values into rows. And string split is a very useful way to do that. Again, cross apply is needed because I want to grab a column from this table, and I want to say for each of these rows and products, do this function. That's what cross apply does. Okay. Okay, let's dive a little bit into program flow control. So to branch in TSQL, you use an if statement. And basically it's if, and then you have an expression, and then whatever's between the begin and the end, that happens when the if is true. Then you have an else and a begin and the end, and whatever happens between that begin and the end is false. And you've seen examples of this before. This is you could do something like this, but where it's commonly used is in schema inspection. We inspect that information schema, and we say, hey, if exists, when I select from information schema this foreign key name, then why don't you drop it? Okay, so that's a great example of using if exists. You can also use if exists to see if a row exists in a table and then make a decision as to whether you're going to do an update or an insert instead. So those are the two use cases of using exists: finding a row in a table and finding a piece of metadata like a column or a table or a constraint that exists that you might need to alter or drop. Okay, there's a couple different types of data logic that exist in the relational database management system. There are views. We've seen views before. There are stored procedures. Stored procedures are like little named programs. There are also triggers. Triggers are stored procedures, but they go one further in that they automatically execute when data changes. So when you delete data, when you update data, when you add data, it's up to you to decide when that happens. Okay, before you update the data or instead of the data being updated, you can have an event fire, and then event that fires could be a stored procedure, or it could just be code that you wrote as an unnamed stored procedure. And then finally, you can actually make your own functions. So we saw, there's the string ag function, and there's a string split function, and there's is null, and we saw the name part function. You can make your own functions as well. And these are all kinds of data logic, and sometimes the answer to the data logic question that you have is a combination of a few of these different things. You might combine a user-defined function with a view, or a stored procedure with a trigger, or a user-defined function with a stored procedure with a trigger. You might have to use a bunch of these things. So these are the artifacts, these are the metadata artifacts that help us build data logic. Let's start with views. So we saw views before. Views are a way to abstract an SQL query and save that query under a name in the database catalog. So when you say create view whatever, you can end up running a select statement over that view. So why are views important? Well, views come into play when, imagine you're building an application, and we'll go back to what we did last week in Unit 9, where we talked about building our database applications and coming up with prototypes and screens and things like that. And so you might have a screen like this in your payroll application that when the user logs in, it says, "Hi, Aurora Borealis, how are you?" And then it shows you the last 4 paychecks for that person. So this query comes from a couple of tables, and therefore, to prepare for this query, you might write a view. So by writing a view, you help the person in the business logic layer not have to worry about how to join all the tables together properly. We do the joining of the tables at the data logic layer in the database, and then expose the view at the business logic layer, so whoever's making this screen doesn't have to know diddly punk about SQL. They just have to know when they ask for this, they get a table of data back. It's a pretty sweet deal if you ask me. So I could create that view, but I think you know how that view would go, so I'm not going to bother to do that. But you need to join the employees table to the paychecks table, right? And then you get all this information for paychecks and that for employee, and then you're actually querying the data with the current user. So at the business logic layer, you'd say the current user is Aurora Borealis, pass that into the view, and then you would get back just the paychecks for Aurora Borealis. Okay. We'll get into more detailed examples when we dive into stored procedures, because you've never seen a stored procedure before. So stored procedure, it's a group of TSQL statements that encapsulate data logic under a single command. You, in essence, name the stored procedure and then invoke it by name. And this helps us build a really robust external data model, because we can create a very sophisticated data logic. For example, we can write a customer record only if the customer doesn't exist. We can create a new bank account, which requires us to insert into several tables. Maybe when the customer signs up at the bank account, they get a checking account and a savings account and a money market account. So you have to open 3 accounts along with adding the customer information. You might do something as simple as when an order is added with a different shipping address than we've had before, that gets changed to the default address in the customer table. That's a great example of a stored procedure. Okay. These are usually business rules that are wanted for some reason or another. There are not things that you and I make up. There are things that our end users want, and then we incorporate into the databases that we build for them. So what are the benefits of stored procedures? Well, they keep the data logic close to the data. The data logic goes in the database. They're isolated from a security standpoint. For example, I can give a user permission to execute the stored procedure, but not give them permission to edit data in the underlying tables. So it's a more secure way of controlling access to the data within the database. Stored procedures perform better than sending TSQL back and forth from that business logic layer to that data layer, as we saw in that example earlier on where I had business logic layer over here and data layer over here. So that improves the performance. Also, the stored procedure itself, all the code within it, is pre-compiled, if you will, so that the database management system doesn't have to read it every time. It just knows what to do with it. And last but not least, it makes it easier for the programmer at the business logic layer to do their jobs, because they don't have to know the intricacies of the internal data model. They can just work with the external data model. So the folks in the middle tier, in the business logic layer, don't have to be concerned so much about what tables are there and what all the rules are within the tables. They're in essence given a contract through stored procedures as to how they should interact with the application. All right, so here's the basic syntax of a stored procedure. You say create procedure, and then you put in the name of the procedure. Then you pass in one or more parameters, and these parameters are variables. And then we say as begin, and then within the begin and the end, there are a bunch of transact SQL statements which do whatever it is we need the procedure to do. Whether it's check for the existence of one data before we insert into another table or whatever. Okay, that's really up to the problem that you're trying to solve with the stored procedure. The real benefit is the procedure has a name, and that when you want to use it, you just call it by name. You just say, hey, procedure, run, execute the procedure name 1. This are 3 different ways to execute the same procedure. You can call them with positional arguments, or you can call them with named arguments, like this. And I prefer to call them with named arguments. I assign the parameter name to the value so that I can specify these in any order I want. I don't have to know the proper order based on the way I define the procedure. How about a demo? All right. All right, I'm back here at Azure Data Studio, and I'm now in the payroll database, and we are going to implement in a stored procedure that exact same demo that you saw from before, where we transfer an employee from one department to another. So to set up this stored procedure, let's take a look at the data in the employees table. Let's just grab a couple of them. So I can take an employee like myself, and I can see that I am in a certain department. And if I move to another department, the supervisor should change because, as we saw, there are different department managers. Let's do this where job title. Okay, let's get the do that. All right, so for example, the manager of the toys department is validation, and the manager of the housewares department is tie it down. So 8 is the manager of the housewares department. So if I take a look at an employee, let's pick on someone. Let's pick on the last 2 employees in here, where employee ID is bigger than, let's just go bigger than 65. Okay, here are my last 2 employees. Right now they're both in the toys department, and their manager is employee 10, because that is the manager for the employees department. So I cannot just update, and I guess this is the gist of the problem here, is I cannot, if I do this, if I say, let me do it up here. If I say update employees, and let's set the employee department to hardware, and let's do that where the employee ID is 66. Okay. Done. And then I come down here. What I notice is that, oh, it did change it properly. Well, that's because I already wrote the trigger, and I probably should get rid of that trigger. Yeah, so the reason it works is because as I was preparing for the lecture, I put a trigger in there already. So let's see here. There's probably a trigger in here. There it is, right? See that trigger? So that trigger's running, and that trigger is cheating, if you will. So it's automatically fixing things for me. I gotta drop that drop trigger. Yeah. We'll add it later. I got to get rid of it. Okay, now let me update that. Let me update it. Let me put it back to toys. And then I'll show you the employees. And you'll see that there's a problem because the departments match, but the managers do not. See that? So I need to do something where every time I change the department, it changes the manager for me. This is why you actually want to implement this as a trigger. because you don't want to think about remembering to run the procedure. You just want it to do it every time you update the data. Okay. However, let's just write it as a procedure to start, and then we'll figure it out from there. So what does it take to actually do this? Before you write the procedure, you need to be able to figure out how to do it without a procedure. Okay. So what I need to do is for any given employee, like employee 66, when I change them to toys, what I need to do is find the manager for toys. So how do I find the manager for toys? I say select star from employees where employee job title is equal to department manager. Let's start there. And now, what's their department? Toys. That's ID 10, right? And employee department is toys. And what I want is the employee ID. Okay, now I have the right employee ID. So now I can say, now that I know the right employee ID, I can say update this guy, update employee 66, set the department to toys, and the employee department, the employee manager, whoop, I'm not getting it because I forgot my comma, employee supervisor ID, to 10 in this case, right? Because see, this query gets me the 10, and then this query says, all right, change the department to toys and change the supervisor to 10. Now I need to use variables. I don't want to hard code. I don't want to hard code 10 and toys in there and 66. What I want to do is something like this. I want to say declare the employee ID to be 66, an int, and let's make that 66, and declare the department to be varchar, I don't know, what is it, 20, and let's make that toys, and then I want to declare the supervisor ID, and I don't know what that is, it's just going to be an int. Okay. Then down here, I want to say, let's set the supervisor ID to the employee ID that I get from this query, and I don't want to use toys, I want to use the department. And then down here, this should be department. This should be supervisor ID. And this should be employee ID. Now I've written this in a way that if I change these values up here, it just works. So let's prove that this works by doing this. Let's do a select before. Select star from employees where employee ID is a 66. And then afterwards, at the bottom, this is how I write all my procedures, by the way. Write it without a procedure first, make sure it works, then turn it into a procedure. So this is the before. Okay, right now he's in the toys department. Okay, let's change the department to customer service. Okay, and they're in the toys department. Let's run this. And then let's run this. Now they're in the customer service department. And their employee ID, their supervisor ID is 5. Now let's change it to the toys department. And then we'll run this. And then we run this. And we changed it to the toys department. And the supervisor ID has also changed back to a 10. So the code works, right? And so basically what I've done is I've written a program that what it does is it first looks up the supervisor ID for the given department. And then it updates the employee table for that particular employee ID using the new supervisor ID in the new department. That's basically it. Now I need to write it as a procedure. These things here go into the procedure, right? Because the 66 in toys, when I invoke it, I want to give it those values. So I say create procedure p transfer employee, and then I need to give it an employee ID as an int and a department as a varchar 20. And then I say begin, or as begin. And then I know it's going to be mad at me here for a couple reasons. I need a go here. Can't create things without batching it with a go. Okay. Also, if I'm going to be in the business of creating, I better be in the business of doing drop procedure. If exists, p transfer employee. Go. Might as well do that while I'm at it. Now, I don't need to declare this because I'm passing it into the procedure at runtime. I don't need to declare this because I pass this into the procedure at runtime. Okay, this goes in the procedure. This all goes in the procedure. This all goes in the procedure. And then I have end down here and another go. So that's the whole kit and caboodle for the procedure, if you will. And if I just run this, I got to do the whole thing, right? Got to highlight it all. It runs. And if I go down here to the payroll database and go to programmability, stored procedures, you'll see that in here is transfer employee. See that? There is, and it has two parameters, an employee ID and a department. And those both go into the procedure. Now that I have made my procedure, it is in the catalog. I can use it whenever I want. So I can say execute p transfer employee. And the first thing I need is an employee ID. And that's going to be, I don't know, 65. And I need a new department. And that's going to be clothing. And let's see what 65 looks like before. And let's see what 65 looks like after we run the procedure. So before the procedure, run the procedure, after the procedure. All right, we took cook my food. And before, cook my food was in the housewares department and had a supervisor of 8. And now cook my food has a clothing department and a supervisor of 4. So there you go. That's the reason for making a stored procedure. Data logic. Data logic because you cannot update this department without also updating the supervisor ID. That's something we don't want to rely on the programmer at the business logic layer to know or even do. So what I would tell them is whenever you need to move an employee from one place to another, don't update the table yourself. Just use this program I wrote for you and it will do it right. That is the idea behind stored procedures and data logic. All right, let's get the skinny on triggers then. Triggers. Trigger is a special type of stored procedure which will execute automatically based on an operation and an event. What is an operation? Operations are any combination of insert, update, and delete. So you can say when the table has data that's going to be inserted, when the table has data that's going to be updated, when the table is going to have something that's going to be updated or deleted. Okay, you can use these inserted or deleted, any combination you want, or all three. Then there are two events. There is the after trigger, which fires when the operation completes. Okay, so that fires after the integrity constraints have all passed. So it's not going to violate a foreign key constraint, not going to violate a primary key constraint, not going to violate a check constraint. all the data is going to go in there. Okay, you're ensured that that's going to happen. And then there's one more thing you want to happen. Okay, and generally when you do an after trigger, you know the data that you want to write is going to be written, and you're good with that. Okay, and instead of trigger fires before the operation completes. Okay, so before the integrity constraints, and the instead of trigger is a way of writing your own data integrity constraint that you cannot express in some normal way with a check constraint or a default constraint. So if there's some crazy data integrity rule that you must enforce, but there's no way to enforce it with any of the normal constraints, you can always write an instead of trigger to do it. Now, we will not demonstrate an instead of trigger today because you don't know enough database stuff yet to do it, because you have to be able to figure out if the instead of trigger fails, how do I undo all the changes I was about to make? Okay, and we'll discuss that in the subsequent unit coming up, where we talk about transaction management. That's when we will demonstrate an instead of trigger. So there are three common use cases for a trigger. The first one is to prevent automatic updates. The second one is to audit changes made to a database. And the third is to ensure some kind of integrity within the database. So we will demonstrate an example that does a data integrity update by dealing with the fact that when you update a department, we want to automatically change that supervisor's ID as well, rather than relying on someone remembering to run the procedure, right? So the advantage of writing this as a trigger over a procedure is writing it as a trigger means you can tell the person in the business logic, hey, just do a regular update, buddy. I got you covered. As soon as you do an update, I'm going to make sure the manager's right. You don't even have to remember to call a stored procedure. I got you. Okay? So that's sort of the reasoning behind using a trigger. Okay, you don't want to get, as I joke around, get trigger happy. The more triggers you have in your database, the more decisions have to be made before every update, and this is going to slow down the amount of updates you do. So here's the basic syntax of the trigger statement. It says create trigger, name of trigger, on which table will the trigger fire. Triggers are associated with a table. And then we have, are you going to do an after trigger or instead of? We're going to stick with after triggers for now. And then what are you going to do? Insert, update, or delete, or all three, or one or two. And then you have begin and end, and in between there you have the statements that make up the logic of the trigger. So something to remember, there are two special tables called the trigger tables. And the trigger tables are temporary tables that are the data that is affected by the operation that caused the trigger to fire. Okay, and they are the inserted table and the deleted table. The inserted table will tell you what data is about to be added or updated. The deleted table will show you what data is about to be removed, or the data the way it looked like before it got updated. So why would you need to know these things? Well, remember, triggers aren't like procedures where you pass in little bits of data and they run. You might update the table in batch. You might update every single customer at once and change something. And so that trigger needs to fire for every single piece of data that's changed. And therefore, you need to be able to write your trigger code so that it works on a set of data rather than working on an atomic row of data. You have to think differently about how you write the trigger. As you'll see, there's a common pattern that you'll use whenever you write a trigger. And it will always involve using the inserted table or the deleted table or both, depending on the context at which you're going to write the trigger. Okay. So let's use the example we did before, and we will write a trigger. We'll write two triggers first. We'll write one trigger that just shows you what the inserted and deleted tables are doing. And then later on, we'll write a full trigger. Okay? Okay, I'm out here again at Azure Data Studio, and I think the best way to really understand how a trigger works is to try to make one that just prints out what's happening with the inserted and deleted tables. So I'm going to do that now. Create trigger. And let's just make this on the employees table because I've been working with this table the whole time. And I'm just going to call it T employees. demo, because it's just a demo trigger on employees after insert, update, or delete. I don't care which one it is. We're going to do it after all of them. And as begin, and then end. And whenever you create a trigger, you probably should drop one. So drop trigger if exists. And we're going to drop this trigger to employees demo. And for now, we're just going to make the trigger do print, so we can just get this code to run. Let's see what we get here. Okay. All right. Create trigger. Oh, on employees, right? There we go. Okay. Now it works. And if I just go look at the employees table, there is now a trigger called employees demo. Okay, so there's now an automated set of code that runs whenever something happens to the employees table. Now let's make something more useful in this trigger. Let's just make it print hi. And then let's do this. Let's update the employees. Let's set the employee last name equal to fudge with an exclamation mark, where employee ID, I think I'm employee ID 1. Okay, let's just do that. And I need to use single quotes, not double quotes. Boy, I am having a mental lapse with that today. And see, it says hi there? It says hi because when I changed this row of data, the trigger fired. And the trigger just says print hi. Okay, it's not a very useful trigger, but it does show me that the trigger's firing. So let's understand inserted and deleted. So a good way to do that is as follows. Let's say select in my trigger. Let's say select inserted. And then let's put after inserted, let's put star from inserted. And then let's say select deleted, comma star from deleted. Okay, let me rerun this trigger. And then let's go back here and let's change this to say Michael Fudge with a bunch of E's at the end. Okay, and then let's run that. And what you'll see is in the trigger, it did 2 select statements. Again, not ideal, but useful for what we're trying to accomplish here. And this first one is inserted, and then the second one is deleted. Inserted is the data as it is going into the table. Deleted is the data as it was. Okay, so before the update, it was Michael Fudge with an exclamation mark. After the update, it's Michael Fudge with a bunch of E's at the end. Right? That's what it means to use inserted and deleted. If this was a delete command, if I change this to a delete command, inserted would be null, and deleted would be the data as it was. If this was an insert command, inserted would be what was inserted, and deleted would be null. Okay, so the only time you see something in inserted and deleted is when you do an update. Good. So that's basically how triggers work. Now I can have 6 triggers on the same table, but you want to try to avoid that if possible. You want to try to write one trigger that accommodates all the business logic, all the data logic you might have in that table. You don't want to complicate things by having a lot of sophisticated triggers set up on the same table. Because remember, every time you make a change to the data, whether it's pertinent to the trigger or not, the trigger fires. All right. Let's write a real trigger this time. And what we're going to do is we're going to take the same stored procedure we wrote, but we're going to rewrite it as a trigger. And you're going to see that it's going to have to be a little different to function as a trigger than it did as a stored procedure. Because as a stored procedure, we're thinking about things as rows of data, but as a trigger, we must think about things in terms of several rows of data. So we just have to think about them a little differently. Writing triggers is not hard. Testing them and debugging them is quite difficult. So once you get the gist of how to write a trigger, they're not so bad, but it can be a little tricky at first, I will say, at the least. All right, I'm back here at Azure Data Studio, and I have set up my trigger. It says create trigger, T employees update department, on employees, after insert or update, begin. I've got to write my trigger code here, right? So basically what I want to do in this trigger is I need to update all the employees, right? And I need to set the employee department to something. I don't know what yet. And I need to set the employee supervisor ID to something. Where the employee's ID equals one of those employees that was inserted, right? Because I don't want to update everybody. I only want to update the ones that changed as part of the trigger being fired. So in order to access, I can't say where employee ID equals inserted employee ID, because this query doesn't know about the inserted table. So to do that, we need to add I want to update the employees table, but I want a reference from the inserted table. So it says, hey, make an update to employees, but the table I want you to reference for those inserts or those updates comes from this table inserted, okay, which I demonstrated earlier. I showed you what inserted looked like, right? And so now there's an aliasing problem, right? So I need to say employees employee ID here. Okay, now I'm getting somewhere. Okay, now what department should they get set to? Well, they should get set to whatever their inserted department was. Okay. What should their employee ID be? Well, you can't say inserted employee ID or inserted employee supervisor ID. You can't say that because we need to look up what the proper supervisor ID should be from the department. So I actually need to do some of the logic that I did before, where I can have a select statement to look it up, right? I can also do that in line here. I can say set this to, see if you can figure this out, select the employee ID from employees, where the employee job title is equal to department manager. I'm going to break it up a bit. And the employee department is the inserted department. I could have done this select statement above the update as a separate command, but this is a better way to write it, because this way, if I update 6 employees, they all get the right department. They all get the right supervisor ID, because I'm looking it up in the time contextually to whatever its chosen department was. Okay. So writing queries like this, it's a little tricky, but it's always the same. Okay. You're going to say from inserted or from deleted, depending on what you're trying to do. And then you need to update or delete something or you need to update something based on whether it was inserted or deleted. Okay, so it's always going to be similar to this. Now, you could have also joined the tables together and done it that way, but this actually ends up being a cleaner way of representing that update statement. I want you to just think about this for a second. I'm updating the table employees, but what I'm using to figure out which employees to update is the inserted table, which eerily enough looks exactly schema-wise like the employees table. The only difference is that it only contains rows that I care about. And that what you're doing is you're saying, well, match the employee ID to the inserted employee ID, and then for that inserted employee ID, make sure you use their inserted department, and then for their supervisor ID, why don't you find their super ID from the inserted department? All right, enough jibber jab. Let's see if it works. So I run the I have it looks like I have a mistake here somewhere. I probably forgot a parenthesis somewhere. Oh, you have this twice. There we go. Okay, there we go. And let's give it a shot. So let's do this. Let's let's show how it works in batches, right? So let's say update employees, set employee department to toys, where employee ID is bigger than 64. Now, before I do that, let's see what it looks like before. And let's take a look at what it looks like afterwards. And let's get rid of the two wheres. So beforehand, I have 3 people. And 2 of them are in toys and 1 is in clothing. Okay, let's change this to hardware. Nobody's in hardware, right? So I'm going to move all 3 of these employees into hardware. Check it out. Okay, not only did I move those 3 employees into hardware, but I also set the proper supervisor ID. The trigger did that. This part of the trigger did that. This part of the trigger right here did that. Okay? It works in a batch. This is where the trigger has an advantage over the stored procedure, right? Is you can do a bulk update and it will update everybody correctly. That's where the trigger ends up being more handy than the stored procedure. So if I want to, let's just change a couple of these. Let's make this bigger than 65 now. Bigger than 65. And let's change these people to, I don't know, clothing. Okay. Now the last 2, they were hardware, and now they're clothing. There we go. Pretty neat. Triggers are cool. Very hard to debug, so you gotta keep them simple, right? Keep them simple. Don't try to do too crazy of logic in the trigger. Okay, let's talk user-defined functions. So you can define your own functions in TSQL. This allows us to take data logic, put it in our databases, make our intentions pretty clear. Function can be used in the same manner as a built-in function. So you can put the function in a select query or in a derived column or part of a check constraint or in the from clause if it's a table-valued function. A user function looks like this: create function, name a function. It looks a lot like a stored procedure. The only thing that's different is it has a return section and it must return a value. So let's do an example of a function from the payroll database. This function is going to get a manager for a department. So you give the department name as input. It gives you the manager ID, manager's employee ID as output. Okay. Now, you should not usually write functions like this. you should write functions that do not perform queries if possible, because you can always solve this with a join. But there may be a very specific use case for this, such as the business logic requires this specific task to be done and needs an ID returned, in which case it might make sense to create a user-defined function. So let's just write this really quickly. All right, in true cooking show method, I've written the function for you and just hopped right out here. That way you don't have to watch me henpeck this. I've got my drop function, create function. It takes one parameter, the department name, and then it will return an integer. And what I do is I use that supervisor ID and I select the employee ID from employees where it's the department manager and the department matches whatever you gave me. And then I return back that supervisor ID. So let's go ahead and run this code to make my function, and then let's use it. Let's try the select star. Let's do select f get manager, and then let's get the manager for the hardware department. And there you go. The manager for the hardware department is 7. Let's get the manager for customer service. 5. So why have a function like this? Again, think of the business logic layer. In the business logic layer, someone may need a feature in the application that, given a selection from a drop-down of customer service or hardware, it retrieves back the manager's ID back to the application. This function would be very appropriate for that. So the API to make this work would just be, from a programmer standpoint, in the business logic layer, this code on line 20. And then this is the value that they get maybe from the drop-down list. So you very simplified it. They don't have to do all this stuff to make it work. So that's a basic example of where you might want to use a function. Okay, let's wrap it up with table-valued functions. Table-valued functions are non-scalar select statements wrapped in a function. So unlike views, table-valued functions take parameters as input. So if you've ever thought about making a view and you say, well, I want to be able to pass in like an employee ID into the view, then a table-valued function is probably a better choice for you in that situation. So unlike a view, a table-valued function can contain multiple SQL statements. So it looks just like a regular function, except it says returns table as. And what you do is when you call it with a select statement, you say from, and then that is the function, because the function returns a table. So here's a table, if you will, that outlines the difference between a view and a table-valued function. And the main difference is that a table-valued function can't have triggers, and it does accept parameters. So if you need to have triggers, then you can't use a table-valued function. Views, on the other hand, can do that, but you cannot put parameters on views. So here's a use case for a table-valued function, right? We had that my paychecks view that we talked about before, right? And what we're going to do is, rather than use a view, we're going to write it as a table-valued function, because it might make sense. Because when you log in, you're going to have an employee ID, like Aurora Borealis' employee ID, and then that is going to be used to generate the input into the view to give you just her paychecks back. So this is actually a better use case for a table-valued function than it would be for a view. Okay, back in Azure Data Studio, here is my view, my payroll view. But remember, most of the time when you look at this payroll view, you're going to be picking on the paycheck history for one particular employee ID. You're going to say, where employee ID is 66. And then you're just going to get the payroll info for Aurora Borealis in that case, right? So instead of writing this as a view, maybe we want to write this as a table-valued function, okay? So it would look like this instead. Okay, let's do drop function, and let's do f my paychecks. That's the name of my functions. And then it's going to take an argument, emp id, int, and it's going to returns a table as, and then what is it going to do? It's going to return, and let's just do select star from v payroll where employee ID equals emp ID. Okay, now you might say, I don't really see how this is any better than what I had before. Well, I mean, that's why you got to see how it ends up being invoked. So let's put a go up here, and let's do drop function if exists that. Then this guy up here should be create function, right? There we go. That's better. And it's still complaining about something. You probably need to go here, separate things out. Okay. So that should make my function. Now let's call the function. So select everything from. Now this is what the program in the business logic layer is doing. I'm going to just query this from, not from a table, but from DBOF my paychecks, and then in here I'm going to put the employee that I want to see the paychecks for. That's the logged in employee. So then this shows me the paychecks for that logged in employee, or I can pick a different logged in employee. And so it becomes easier for someone to write this code as an API because they don't have to know any specifics about internally how we're getting that employee. Okay, so that's basically a table valued function. Now, if you want to apply this function to everybody in a table, then I would have to use cross apply. I'd have to say from employees, right? Cross apply, as we did before, this function. And then rather than using a 1, I can now use employee ID. Okay. It doesn't make a lot of sense to do that in this case because this query already includes employee information in it. So there's no reason to write the function this way. So you have to really think long and hard about why you have your table value function and the reason for the way you're writing the table valued function. So this is, I would put this down as a no, don't do it this way, right? And then the yes way of doing it is just like this, right? Just pick out the function to get the employee that you want and just go about grabbing the employee that way. And the thing to remember is this is sort of functioning as a where clause, right? Except it's got a parameter in it. Okay. Okay, that was a long one. Let's sum up. SQL programming is useful for creating data logic. Data logic is strictly focusing on the CRUD operations, that is the reading and writing of data to a database. Create, read, update, delete. There are 4 types of data logic in most relational databases. They're views, procedures, functions, and triggers. And functions, you can have table valued functions and regular functions, right? Scalar valued functions. And you can see procedures are great for manually invoking data logic, whereas triggers are great for automatically invoking data logic based on an update to a table. So that gives you a basic idea of the different ways that you can interact with a database through data logic.